I greet you, ladies and gentlemen, at this time, as I'm ready to present to you on hypothesis testing. In my previous video, I promised you that I'm going to do a presentation on hypothesis testing. At the end of the previous video, where I was doing data transformation and also demonstrating calculations pertaining to measures of central tendency and also measures of dispersion, I concluded by briefly introducing hypothesis testing. I want to proceed from where I left. So we are still using the same work file, which is the Senley work file. We are still using the Senley work file. So we are proceeding with our data analysis. And what we now want to analyze, we want to analyze dependence or independence between variables. We want to analyze dependence or independence between variables. So we go to analyze, compare means. Instead of the one sample t-test which we did in our previous video, we click on independent samples t-test. So the test variable in this case, the test variable will be, say, total expenditure. Total expenditure. The grouping variable will be average income. Let me check. On average income, it's a challenge to make it the grouping variable because we don't have two groups. On average, it's a scale variable where one had to specify. So we can look at something like, say, the type of heating, whether gas or solid fuel. We make it the grouping variable, where 1 represents 1 and 2 represents 2. And then we continue. Click OK. So here we're looking at total expenditure. Just total expenditure in general. When we look at total expenditure, vis-a-vis the type of heating, mainly gas, mainly solid fuel. The first null hypothesis is that equal variances are assumed. Equal variances are assumed. Equal variances of total expenditure on mainly gas and mainly solid fuel are assumed. If you check your F statistic, it's 0.164. And the significance probability of that F statistic is 0.686, which is above 5%. So it means we fail to reject the null hypothesis and conclude that total expenditure on gas and solid fuel is the same, and that total expenditure on both is not independent or on either. If one spends more on gas, it implies spending less on solid fuel. So these two samples are not independent. Subsamples, that is. So that's what we can deduce. And then the other thing that we may do in this hypothesis testing, we may want to know whether expenditure is really sensitive to the gender of people. Is really sensitive to the gender of people. The gender. If we go to gender, there we see how it is quoted. 1 is male, 2 is female. So we may want to analyze whether total expenditure varies between men and women in this village, the Sandy village. So compare means independent samples. Now, the grouping variable is gender. It is gender. And then we define 1 is 1 for male, 2 is 2 for female. We click OK. We've defined our groups. Now, if you check, you realize that we have got the first table of group statistics, that there are 124 males and 98 females. 98 females, which gives us 222 respondents in this study. The arithmetic mean expenditure for men is 112,687.879 Hungarian forint, with a standard deviation of 60,811.179 Hungarian forint. And the standard error of the mean is 5,461. Whereas for women who are 98, their average expenditure is 83,249.86 when we round off to the nearest decimal place, with that standard deviation of 47,285.22675 Hungarian forint. And then the critical part is the test that we have for equality of, for the test of independence, the Leven's test for equality of variances. If you look at the F statistic, it's 3.756, but the significance probability is greater than 0.05. It is greater than 0.05. So since it's greater than 0.05, it's 0.054, it means equal variances are assumed. If equal variances are assumed, it means expenditure on expenditure among men and women insanely does not really vary, because we are assuming equal variances. And then equality of means. The arithmetic means are so divergent. There is a divergence of around 40,000, almost 40,000 Hungarian forint, with 112,687 and 83,249.85. So with that kind of divergence are the arithmetic mean expenditures on whatever they are spending on housing, types of heating, and other amenities or social facilities. Is the expenditure the same on average for men and women? We want to check. If you look at the T value, the first T value is 3.942 with the 220 as degrees of freedom. And then the significance probability is 0, meaning to say we reject that null hypothesis of equality of means. And then when you are looking at the second, equal variance is not assumed. When you look at the test for equality of means, we have a T statistic of 4.058 with those degrees of freedom which are almost 220, and the significance probability value of 0, which is clearly lower than 5%. So we reject the notion that these two mean expenditures among men and women are the same, that they are the same. So we reject that. And then we want to look at, now we want to be a bit more specific, because in this survey, the specified expenditure as expenditure on heating, expenditure on electricity, and so on. So we go to analyze compare means, independent samples, Ttest. And then instead of total expenditure, we select average expenditure on heating. Because if it is total expenditure, it's total expenditure on all of these things. But we want average expenditure on heating. That's what we're interested in. On heating in Hungarian forint per month. And the grouping variable has to be gas or solid fuel. It has to be gas or solid fuel. The grouping variable has to be gas or solid fuel. That's our grouping variable. And then I define the groups as 1 and 2. I continue. And then if you look at the calculated statistics, I will omit this table above because it's just covering descriptive statistics, the group statistics, per average expenditure on mainly gas, mainly solid fuel. If you look at on gas, it's 20,300 Hungarian forint. On solid fuel is 33,000. It's higher, 33,917.6. But what I'm interested in is to test the hypothesis of independence among the two groups. So if we look at these statistics, you realize that the F statistic is 5 0.012, its significance probability is 0.026, which is lower than 5%. So clearly we can easily conclude that average expenditure on heating with solid gas or solid fuels are not equal because we are rejecting that null hypothesis. Equal variances are assumed. So if we reject that statement that equal variances are assumed, it means we are accepting the alternative hypothesis that equal variances are not assumed, which is why there is a gap there. We don't need to calculate for that. Equal variances are not assumed. So that's the statement that we accept when we reject the null hypothesis for the critical alpha of 5%. So our conclusion is that average expenditure on heating of households, heating with gas or solid fuel, are not equal. They are not equal. They are not equal. So that's that on this kind of hypothesis testing. In a subsequent video, I will do more hypothesis tests like chi-square testing and so on. But for the purposes of this video, I'm going to conclude with the non-parametric tests, to test for the normality of a distribution. So we go to analyze non-parametric tests. We go to legacy dialogues, and then we go to the one sample Kolmogorov Smirnov test. KS stands for Kolmogorov Smirnov test. The non-parametric test. The null hypothesis is that the variable under consideration follows a normal distribution. And the alternative hypothesis is that the variable under consideration does not follow a normal distribution. So the null hypothesis is normal distribution, the alternative, not normal distribution. And our alpha, for hypothesis testing purposes, our alpha is equal to 5%. That's the standard alpha. So the variable that we choose is average expenditure on heating. Average expenditure on heating. We may interest, maybe I will just do for the two distributions, the normal and the uniform distribution for this average expenditure. We check the options. You can also calculate descriptive statistics if you are interested in those. And then we click OK. If you check, you realize that we have got descriptive statistics, which I clicked when I had finished my narration of the hypothesis test. But what we are really interested in is the results or the output of the one sample Kolmogorov Smirnov test. The mean is 31,727.1, and the standard deviation is 25,014.693. And then it's a two-tailed test. And the test distribution is that this variable, average expenditure on heating, follows a normal distribution. The asymptotic significance two-tailed probability calculated statistic is 0%, which is lower than our critical probability of 5%. If it is a two-tailed, it will be 0.025. So we reject the null hypothesis because 0 is lower than 5%, and conclude that average expenditure on heating does not follow a normal distribution. I just want to make an observation about one sample Kolmogorov Smirnov test. For those who either don't know statistics or for those who have forgotten their statistics, their elementary statistics. The one sample KS test or the one sample Kolmogorov Smirnov test is a procedure or a technique which compares the observed cumulative distribution function for a variable with a specified theoretical distribution which can be normal as well. So we compare the observed cumulative distribution function for a variable, in this case average expenditure on heating, with a specified theoretical distribution which can be a normal distribution. And here the conclusion clearly is that the average expenditure on heating does not follow a normal distribution. Doesn't follow a normal distribution. A normal distribution, we know is a mesochaetic bell-shaped curve around your histogram of information. So you can easily see why we are saying the average expenditure on heating does not follow a normal distribution. We go to descriptive statistics, analyze, and then descriptive statistics, we go to frequencies. We take average expenditure on heating. And then we look at charts. We want to come up with a histogram with showing the normal curve on the histogram. We continue. We click OK. Let me just recalculate after closing the previous results. We analyze descriptive statistics, frequencies. We check once more this side. We check that side. We want to come up with the histogram, which is showing a normal curve on the histogram. And then we click OK. If you check, we've calculated all those other statistics which were ticked. I won't dwell on them. If you look at this histogram, information is skewed to the left. It is skewed to the left. A normal distribution does not have a long tail like this on the right, and it's not skewed to the left like an F distribution or a chi-square distribution, which is reversed, sort of. So clearly, this is not a normal distribution. A normal distribution is bell-shaped. So it can be clearly seen. And then I said, we may also test whether average expenditure on heating, whether it follows a uniform distribution, for instance. Click OK. We start with the descriptive statistics in the top table. And then the table of interest is the one sample Kolmogorov Smirnov test output table, which shows us that the Kolmogorov Smirnov Z statistic of 8.909 has got an asymptotic significance probability of 0, which is lower than 5%. And we conclude that this variable of average expenditure on heating does not follow a normal distribution. I mean, does not follow a uniform distribution, because the test distribution in this case is the uniform distribution. It is the uniform distribution. And then we can also mount a hypothesis which are a bit more elaborate. For instance, we can test the hypothesis that average expenditure on heating of households, heating with gas and households heating with solid fuels are equal. If we know that the average expenditure on heating does not follow a normal distribution, so it's a more like a convoluted hypothesis test. You can mount very complicated hypothesis tests, provided you know what you want to achieve, and that's what you set out to achieve in the beginning. So once more, the null hypothesis in this case will be the average expenditure on heating, the average expenditure on heating of households, heating with gas and households heating with solid fuels are equal. So the average expenditures on households heating with gas and those heating with solid fuel, the average expenditures are equal. And then the alternative hypothesis obviously will be stating the opposite, that the average expenditure on heating of households heating with gas and households heating with solid fuels are not equal. Are not equal. So in case of a non-normally distributed variable, we should use a non-parametric test for hypothesis testing. So according to the menus, we go to our analyze non-parametric test, and then we go to two independent samples, and we get that window. The test variable is clearly average expenditure on heating. Average expenditure on heating. And then the grouping variable is the type of heating, which is gas or solid fuel. 1 for gas and 2 for solid fuel. And then the test that we are going to mount here is the Mann Whitney U test. It's the Mann Whitney U test. That's what we are going to mount. There is also the Kolmogorov Smirnov Z test, and the most extreme reactions, and the world all for with runs, but we are going to mount the Mann Whitney U test, which is suitable for testing that hypothesis. When we know that we are dealing with average expenditure on heating, which is a non-normally distributed variable, we click OK. After clicking OK, we discover that the Mann Whitney U statistic is 4,020, and the Wilcoxon W statistic is 6,500. 576, and the Z statistic is minus 0.743. The asymptotic significance probability for a two-tailed test is 0.458, which is way above 5%, which means we failed to reject the null hypothesis. What is the null hypothesis? The null hypothesis is that the average expenditure on heating of households heating with gas and households heating with solid fuels are equal. So our conclusion is that average expenditure on heating, either with gas or solid fuel, is just basically the same. It's basically the same. That's what, given that average expenditure is a non-normally distributed test variable. We can have another test variable. Another test variable might be, instead of average expenditure on heating, we might have average income. Average income. We might have average income. Average income in Hungarian forint per month. And then the grouping variable might be gender. Might be gender. This is based on the assumption that average income does not follow a normal distribution. You'll have to check that. So want to have the grouping variable being gender, where 1 stands for male and 2 stands for female. And then we click continue. We click OK. We start with the rank, the Mann Whitney test, the rank statistics. And then the table below that is the test statistics output table, where the Mann Whitney U statistic is 3,860, and the Wilcoxon W statistic is 8,613, and the Z statistic is minus 4.266, and the asymptotic tail probability value is 0. Is 0. So what is the null hypothesis? The null hypothesis is that average income average incomes are the same for men and women, because our grouping variable is gender. So average incomes are the same across sexes. And the alternative is that average incomes are not the same across different genders, between men and women. They are not the same. So when we check that asymptotic significance tail probability, we reject that null hypothesis, that average incomes are the same for both men and women. And we conclude that average incomes are not the same for both men and women. So for today, I believe I've done justice for this installment of hypothesis testing. I will do another video to do other different kinds of hypothesis testing, to demonstrate other kinds of hypothesis testing in SPSS. I believe this video has benefited you to understand how you can mount hypothesis tests based on confidence intervals, and also hypothesis tests to test whatever distribution, be it the normal distribution, the uniform distribution, the exponential distribution, or the Poisson distribution. which are the distributions that are offered by SPSS. So I thank you so much for joining in. I believe you benefited from this installment of the lecture. Remember to like this video, to comment on this video, to assist me to improve future videos. And also remember to share this video on your social media platforms so that it's not only you who is benefiting, but it's many of your colleagues who are also benefiting. I greatly appreciate your investment of time. There are trillions of videos on YouTube and other social media platforms for you to watch my video. I know it's an exclusive economic decision. I don't take that lightly. I greatly appreciate it. Have a nice day.